Welcome to another lecture of our DBMS playlist. Today we are going to learn about second normal form or 2NF. So what are the rules to be in a 2NF? The rules are that a relation must be already in first normal form. The relation always must be in first normal form. And what are the second rule? That the relation should not contain any partial dependency. The relation should not contain any partial dependency. What does this second rule mean? So let's check. That is, all the non-prime attributes should be fully functional dependent on candidate key. Okay, so I have already taught you what is non-prime attributes in my previous videos. So don't worry, I will also teach you now again. So again, just see it again. So all the non-prime attributes of the set of functional dependency, where we will be having our set of functional dependency, we have to see that if all the non-prime attributes are fully functional dependent on the candidate key. Okay, there should not be any partial dependency. That's the main criteria, no partial dependency. Okay, now let's check what is non-prime attribute. The attribute that does not belong to the candidate key are called non-prime attribute. Okay, suppose in a relationship we have 4 attributes A, B, C, D, and the candidate key is B, C. So the non-prime attributes are A and D. Okay, and prime attributes are B and C. So suppose we have an example here, that is CID, shop number and location, and here our candidate key is CID, shop number together. Okay, so now let's check. If the location attribute, this is here the non-prime attribute, because location attribute is not contained in the candidate key, so this is the non-prime attribute. So if it is fully functional dependency or partial functional dependency, let's check. So see, whenever the shop number is 1, the location is Delhi, and whenever the shop number is not 1, it is something different. Suppose like what we can say from this, that only the shop number attribute is enough to determine the location. The whole candidate key is not needed to determine the non-prime attribute. Okay, only a part of the candidate key can determine the location column, location attribute. So this is partial dependency. Okay, so then this table is not in second normal form, because there is a partial dependency. That see, shop number alone can be determined. Shop number alone can determine location attribute. So this is partial dependency. So this is not in 2NF. Okay. So now let's check another example. This is, I think, an example of a gate question or something. So let's see and try to solve it. So there are 6 attributes, and these are the FDs which we have. And what are the steps we will be doing it through? First we need to find the candidate key. Then we have to point prime and non-prime attributes. Then the other thing. So first let's do it one by one. So how to find the candidate key, that I have already told you in my last video. What is the trick to find the candidate key? So first we need to find that which attribute is not on the right hand side of any functional dependency. So see, A, B, F and D, these are present on the right hand side. So the only attributes which are not on the right hand side are C and E. So whatever there may be the candidate key, CE must always be there. Okay, there can be something extra also, we will check that later, but CE must be in the candidate key. So now let's check the attribute closure of CE. So what the CE can determine, let's see. C can determine, first CE can determine themselves. Also C can determine F. E can determine A. CE together can determine D, and as we have A already, that is E can determine A and A can determine B. So we can say by transitive dependency that C can also determine B. So you can see that C can determine all the attributes present. Okay, so CE is a candidate key. So CE is a candidate key. C is closer. So C is a candidate key. Okay, so what is the candidate keys? At least we have one candidate key, that is CE. Now let's check for others also. So if C or E is on the right hand side of any attribute alone, so let's see. No, C and E is not on the right hand side of any other functional dependency. So no other attribute can determine C and E. So that means only candidate key is C and E. So what are our prime attributes? Prime attributes are C and E. And what are our non-prime attributes? These are A, B, D, F. These are our non-prime attributes. So now we will check again. The first two step is done. So now let's go to our next step. So we check if there is a partial dependency or not. Okay, so we need to check if there is a partial dependency or not. So here is a condition, that is how to check partial dependency exists or not. So there is AND operator in between, and there are two conditions on the left and right side of the AND operator. So let's see. The left hand side should be a proper subset of candidate key. So what is a proper subset? Suppose CD is candidate key, then the proper subset of the candidate key will be C and D. Okay, so this is what a proper subset is known as. So the left hand side of the functional dependency should be a candidate key's proper subset, and the right hand side should be a non-prime attribute. So if these both conditions satisfied, then only this AND condition will be true. So if these both conditions are satisfied, only then we can say that this FD is a partial dependency. Okay, so now let's check this condition for all four FDs. So C determines F. What was our candidate key here? Let's see. Our candidate key was CE. So our right side of the functional dependency is what? It is a non-prime attribute. So this is true. And the left side is what? It is a proper subset of the candidate key. So this is also true. So then what? Then C to F is a partial dependency. Okay. Let's check for others also. Though we have our first functional dependency as a partial dependency, so we can say that this whole relation is not in second normal form, but whatever, let's check for the others also. Okay, so our next functional dependency is E to A. So let's check again. E is what? E is a proper subset of our candidate key on the left hand side, and A is a non-prime attribute. So this is also a partial dependency. So we got two partial dependencies. Now let's check for the next. EC determines D. So we can say what from here, that EC is our candidate key. It is not the proper subset or anything. It is the whole candidate key, and D is a non-prime attribute. So this is not partial dependency. This is full dependency. Okay, this is A to B. So B is a non-prime attribute. Okay, so this, that is the right condition of the AND, is true. But is A a proper subset of candidate key? No, our candidate key was CE. Okay, so A is not a proper subset of candidate key. A is something, another non-prime attribute. Okay, so this is not true. The first condition is not true, but the second condition is true. But as we can see, the AND condition is there between these two conditions. So if both are true, only then it will be a partial dependency. So it is not a partial dependency. It is not also a total dependency. It is what? It is a transitive dependency. Okay. So I have broken this table into three different tables. Okay, these three are different tables with these attributes. Okay, so here we have three attributes, E, A and B, and here E is our candidate key. E is our candidate key. Okay, and what are the functional dependencies here? So let's say FD is, let's check from the actual table, that E can determine A. So this functional dependency belongs to this table. Also A can determine B. Okay, so if A is our non-prime attribute and B is also a non-prime attribute, so this is a transitive dependency but not partial dependency. So this is in 2NF. Also here candidate key is C, and FD is C can determine F, this one from our actual table, and here the candidate key is EC together, and functional dependency is EC can determine D. Okay, this one. So that's how I have broken our relation or our table into 3 different subtables, and all of these are in 2NF now. Okay, because there is no partial dependency. So that's how we convert, we check at if a relation is in 2NF or not, and we also break down it to smaller tables or smaller relations who are actually in 2NF.